Again, I'd like to welcome you all to AI and Deep Learning for Enterprise. This is our 21st meetup and our first of the new year, so thank you all for coming. A very quick bit of housekeeping before we get started. I'm your host, Hugh, and I'm also joined by Jamari, who is running AV this evening. If you have any issues with venue or you need to talk to me about anything regarding a code of conduct issue or anything similar, and more on that in a moment, please do come and say hi. Speaking of our team, we are a growing team. Adel has now been running for 2 years, and we have hosted a lot of events. If you are interested in getting involved in hosting a meetup all about applied AI, whether that's getting involved in social media, or in live streaming and producing video content, or in hosting, or in booking speakers, give us a shout. We're not just looking for people to come in and do the work. We really, we've learned a few things since we started running this. So if you want to come learn how to, for example, do AV on a very shoestring budget, you can come talk to us and we'll teach you some things. Secondly, if you'd like to speak at one of these meetups, you don't have to be a world expert, although certainly we've got some really exciting speakers this evening. Feel free to submit a proposal to our CFD. As long as your topic is applied AI, we will work with you to get that presentation where it needs to be. Doesn't matter if you're a first-time speaker or if you're new to the field, give us a shout and we can figure something out. Finally, we have a code of conduct that governs all of our events. Here's a mini version. We want to create a safe and welcoming community for everyone who comes to our events. We want to create an environment where, it's like a friendly setting, but we want to keep things professional, right? Like anything that wouldn't be appropriate at work isn't appropriate here. And we want to treat our hosts and our venues with respect. For the full version, you can scan the QR code here. It's a variation on the num-focused code of conduct, which I'm sure many people will be familiar with. But with all that out of the way, I'd like to quickly run through our agenda for this evening. So up first, we have Rachel Lee Nabors, a fractional developer experience leader who's going to be running us through a quick AI ML Cram session. Next up is Rhea Mendonca, a master's student in data science at Greenwich University, who's going to be talking about unlocking the potential of dark data with machine learning. Last but not least, we have Jason Chao, director of Hongkongers in Britain, who's going to be talking about understanding immigrants' challenges with the help from LLMs. So I will just quickly skip over this, and I'm going to hand over to our first speaker, Rachel.
Hello there. I am Rachel Lee Nabors. Oh, wow, that looks awkward. Don't look at the iPad. I'm Rachel Lee Nabors, and I am here to help you navigate all of the wonderful acronyms that you no doubt have been exposed to. Before I get going, I'd like to know a little bit more about yourselves. How many of you have trained a model? Put your little paw in the air. Okay, sweet, sweet. How many of you, on the other hand, don't know what GPT stands for? This is a safe space. It's okay to admit it if you don't know. Okay. All right. Yeah. Don't worry. We're going to fix that. And for the rest of you, just pretend you look surprised. Do me that favor. How many of you know what a perceptron is? Okay, well, good. The rest of you are going to learn a couple of new things tonight. I'm glad. Now with all of your levels, just pretend you're at the beach. We need those vibes right now. Ignore that. Okay, here we go. So, are any of you web developers who've worked with something like React before? Okay, yeah. So you might remember me from my work over the pandemic with the React core team. Right here in London, we built react.dev together, and I wrote react.native.dev. It was a lot of fun. But then, front-end development felt kind of maxed out, and I spent 2024 learning all about AI. It was this book right here is like the best 60 pounds you can spend. Does anyone have this book or has read it? Don't give away the ending. Anyway, it's been the theme of my most popular TikToks. It's gigantic, it's thicker than a brick, and it provides no end of delight and wonderment. My best TikToks are just me walking through algorithms that I've read about in the book. But believe it or not, before my big tech career, I made comics for teenage girls. And you'll notice that all of the doodles were done by myself. I did not use an image generator. I'll be quite honest, because I've done art for a long time. When I see AI art, it kind of makes me want to vomit a little bit, like motion sickness. I don't mean that to disparage the art. I just mean it's like, my mind is like, oh, alternate reality, gross. I feel sick. I don't want to know. All right. But while I did doodle Claude here, I feel like I'm on the wrong side. I should tap. While I did doodle Claude here, Claude actually did help me put together the outline for this particular talk, because I was like, hey, you got to use the technology if you're going to talk smack about it, you know. And I also love Claude. I think Claude is a lot better a collaborator for me than ChatGPT. With ChatGPT, I always feel like I'm talking to Elon Musk. But with Claude, I just feel like I'm talking to my big sister. So, and I also had some help from my co-worker at Tiny Fish, Wenji, and a friend named Lisa. All right, so Claude is going to stand in for other characters of his ilk for the rest of this talk. And when I say other characters, we're talking about Mistral, Gemini, ChatGPT. Llama's not in there because Meta is too cheap to give its open source projects logos. I should know. The React logo was donated. And now, as many people know, those were all, well, maybe you don't know, but those were all a bunch of LLMs and GPTs. The goal of this talk is to fill in any missing gaps you might have, because we hear AI thrown around an awful lot, but what exactly does it mean? By the end of this talk, you're going to understand the evolution of narrow AI towards artificial general intelligence, how neural networks underlie deep learning, what a GPT really is. I know you know what it stands for, but do you know what it is? And different ways to teach a model. And lastly, what vector databases and embeddings are and why they are so handy. Now, let's get started. First, let's get clear about artificial intelligence means. Intelligence means different things depending on who you talk to. Right now, for instance, it means one of two things, just depending on whether you're talking to someone who's trying to sell you compute or you're talking to like a machine learning scientist. So LLMs, like our friend Claude here, are one form, but when we talk about artificial intelligence, we're talking about usually artificial general intelligence, which is kind of like what we think of when we imagine science fiction movies, you know, all the things you see in Black Mirror, artificial intelligence compared to, you know, GPTs, which are what we're using right now. So artificial general intelligence, which we'll use now to distinguish between the two of them, is as human as human. And there's still debate about what would constitute artificial general intelligence and when it will arrive, but there's some general agreement that it should be able to transfer knowledge between domains. It knows about cupcakes and it knows about horses. It would understand what a cupcake horse would look like and why it wouldn't be alive. Possess common sense reasoning, like a small child knows not to drop a ball or a glass object because it won't bounce. I didn't know that for a long time. Learn from very few examples. Monkey see, monkey do. Not monkey see a million other monkeys, monkey try and fail. Handle uncertainty and novel situations. I struggle with that one. And understand context and nuance. Also struggle with this one. I gotta tell you, reading through that green book, I was like, are they describing autism? Some of these tips are very handy. It's like, oh, it's better for the intelligence to not have a defined set of variables. Like it shouldn't have a defined outcome. It should be trying to understand what your defined outcome is. I'm like, you're talking about my old director. But no, it's fascinating to study this line. But some things we assume are components of intelligence as we know it, artificial general intelligence doesn't necessarily need. Like viruses, are they alive? They meet a lot of the definitions, but they definitely don't seem alive. So Does artificial general intelligence need to be conscious or aware? Well, first we'd have to know what makes something conscious or aware. And last time I checked with the FDA, they did not think too highly of that when we apply it to animals. Think or reason the same way that humans do. I mean, I have no idea how some people think. So I think even there we struggle to set a standard. And have emotional intelligence, for instance. Yeah, there's so many people who don't have that. I feel like we're setting the bar really high if we're going to include those things in our definition of intelligence. A lot of our species would just have to opt out. So, all right. So let's talk a little bit. Here's our spectrum. Everything comes in spectrums. And here we've got our spectrum of AI. So narrow AI does one job really well, like playing chess or identifying cancer. That's good, it's smart. It's more human than human. It's better, it's super. Then we've got AGI, which would be as good as a human at making decisions, doing multiple things. And then there'd be super intelligence, which would be better than human, in which case, let's all give up and just accept that we're cattle now. I mean, we basically have like raised a teenager to be more mature than us and accept that we need to go to the retirement home. So what we currently have is still narrow AI. Even GPTs are just really good maps of human language. They're really good at that one thing. They're not good at math. They're not good at making decisions. They tell you what they think probabilistically you want to hear next, according to the map. That's not intelligent, that's just, well, you'll see. So there we go. Let's take a look at how we got to where we are today. We'll get rid of these acronyms. So if that's the goal, where did it all start? It started with the perceptron algorithm. We are marching towards AGI, but it started way back with this right here. This is the perceptron Mark I machine, the first implementation of this particular algorithm. Perceptron was the first machine learning algorithm designed to mimic how a biological neuron works. Neurons, like the ones that are in your head right now. They trade signals with one another. Anyway, it's a really cool looking machine, even though it's highly pixelated. You can go see it at the Computer Science Museum in the Bay Area. Back in the day, there were claims that it would be able to reproduce itself and be conscious of its own existence. Those turned out to be overhyped, resulted in the first AI winter. We're probably going towards the second or third, depends on how you're counting, but who's counting? So yeah, the algorithm was designed in 1943. It was implemented only 14 years later in 1957. And it did prove that machines could learn by example. You could of course, it was the beginning of the winter because they could learn, but did they have enough compute to learn anything of use? This is a little diagram of how it works. What happens is this is a retina, it detects light. So just like the retina in the back of your back of your eye. And each one of these is going to give a value, yes, no, for if it's lit or not. Each input has a weight, which gives it importance. For instance, maybe the ones in the center are deemed more important than the ones in the periphery. And you add them all up. You add up all the weighted inputs, and if the sum exceeded a threshold, it's going to output 1. Otherwise, it outputs 0 to let you know whether or not there's light to be detected in this room. Note that there's just one layer of these little perceptrons perceiving these inputs, just one layer, right? Now this is actually a machine learning. It looks deceptively simple, but you know, your brain is deceptively simple too, and yet it does complex and miraculous things. You throw enough things against the wall, eventually it makes sense. But this is very important. The neuron design is going to come back to us. Turns out if you make a bunch of these perceptron layers, you stack them super deep, you let them pass information to each other, you've created a neural network. It's loosely based on how our neurons work, but at this point we're just dealing with math and equations. If you want to actually get your fingers dirty by, I've told you this, but maybe you want to actually build a perceptron. Maybe you actually want to make something a couple layers deep and have it show you how the math works. Highly recommend this book, Deep Learning by Andrew W. Trask. Deep learning is a subset of machine learning. It uses neural networks with multiple layers as opposed to a single layer. They're very good at pattern matching. It needs lots of data and power, but it doesn't need structured data, which makes it very handy for just throwing large data sets that haven't been labeled or sorted through or qualified in any way. So if this is machine learning, what's deep learning? What's the difference? It's let's see. Oh, pardon me. I did actually go build my own little neural network with that. It was fun. Anyway, I always like to tell people it's not magic. It's just a lot of math, which is important because right now many people are trying to sell AI this, AI that, AI, use RGPT. This one's better, etc. And I think there might be a risk that people will start to think that AI is kind of some magical thing we don't understand. It does have a lot of complexity to understand how it arrives at what it does, but once you understand how it's doing it, you understand how it might not be good at, for instance, doing certain things. Like why you shouldn't ask ChatGPT to do your taxes. So, for me, when I looked under the hood of React, I was disappointed because I was like, it's just JavaScript. It's not even very good JavaScript. And when I looked under the hood of neural networks, I was like, this is just math. It's not even very important math. Why did it take humans so long? You developed this in like the 1943. What's wrong with you people? Why? It's very disappointing how slowly we evolve. But we're getting faster, and hopefully this will make us faster too. Anyway, so let's look at the depth in layers of modern neural networks. Yay, scale, visuals. So this is AlexNet, came out in 2012. You could think of it, it only has 8 layers. Now you can imagine this on a human scale as being like a single-story home, like a ranch house in Texas. VGG came out in 2013, 19 layers deep. Think of it as like an office building, okay, right? You can see how it's getting faster and bigger. 2015, we got Google's, we got ResNet 50. It's 50 layers deep. And then, we got Palm from Google, 118 layers. That's what we have, I think, currently when I wrote this. So it's about the size of a skyscraper. So we went in 10 years from a single-story home to a skyscraper in terms of depth. Currently, GPT-4 is about 120 deep from leaked documents, so that lets you know how many layers there are. We are currently at a point where we are not sure if adding more layers to make the networks, going to make the GPTs or the LLMs smarter, as it were. We may have hit a wall there. Let's talk about my favorite movie. Has anyone seen The Arrival? Yes! You, sir, have flown a lot of international flights. This is a great book, a great science fiction movie. It made me cry. I don't cry a lot, but I cried during this one. I'm not going to spoiler any of it, but apparently during the pandemic, some researchers watched this and it inspired Google Brain. Because the very problem that our linguist here encounters trying to decipher this language was the solution for it is actually what makes GPTs work. A neural network designed to decipher long sequences. These could be sequences of anything, musical notes, color, words, just long sequences. Needs a little memory, a little callback to things that were said before. I don't know if you've ever had a fever and you can't remember what you started saying. Well, prior to GPTs, that's how LLMs were. They just kind of randomly garble. All right, so transformers. Break sentences down into tokens, words, groups of words. They turn songs into segments. Here are things you need to know about tokens versus parameters, by the way. You'll hear a lot about them. I always have to remind myself of this whenever I'm about to listen to a podcast. Tokens are pieces of input fed into one of these models. They're the treats you hand your dog. Models have token limits. GPT-3, for instance, can take about 4,000 of them. So you could give it an essay, maybe, but you certainly couldn't give it the collected works of Jane Austen. That would be too much for GPT-3. Parameters are, however, the model's internal learnings. You could train a model on the collected works of Jane Austen, and it could internalize those lessons. And then you could maybe feed it essays about Jane Austen and go from there. But they're fixed after training. They're kind of baked. I find this interesting when we think about training a model. It's sort of like raising a kid. There's a period in which the bones are growing and the mind is learning, and then there's a period where everything just plateaus and they're done. They're not going to learn new things very well. They're not going to learn new languages well. They're probably, all of their behaviors are set in stone, and yeah, this is the same. So to give you a contrast, the parameters are measured in billions, whereas GPT-3 can only take 4,000 or so tokens, bits of new information. Internally, it's dealing with 175 billion parameters. So there's quite a difference. All right, so GPT, what does it stand for? It is a generative pre-trained transformer. You've got transformer from Arrival, and you're basically pre-training it so that it can make new things for you. All right, I feel like we keep using that word, we don't know what it means. Now you are refreshed. So that's right, LLMs are just massive transformers trained on huge, huge amounts of text. And it's all just math. And fun fact, what's also really just big transformers? Image generators. Covering them would take an extra 10 minutes, so we're not going to. And we're just going to move onward. So here's where we are today. We are steadily on the march. I love that OpenAI is declaring it's achieved general intelligence. Well, I'm sorry, general artificial intelligence. But I do think that claim does make the earlier statement rather pertinent. So here's where we are today. It's hard not to take things personally. The trouble with LLMs. So we have no consensus on what intelligence is. But Alan Turing, World War II hero, gay icon, artificial intelligence poster boy, invented this thing called the imitation game, which we now think of as the Turing test. Invented is a strong word. He mentioned it in some writings that you could have a machine and a human in a double-blind test, and if another human couldn't tell the difference in responses between the machine and the human, it would have passed the imitation game. Well, because we couldn't come up with a better definition of intelligence, we've been operating off of that since the 50s. So now we measure a machine's intelligence based on how difficult it is for a human to pick it out from amongst other humans. All right. Sadly, Turing is deceased, partly thanks to the British government trying to make him not gay. Just a gentle reminder that queer people have been here in silence contributing to society and technology, and you're welcome. So yes, Alan Turing did exist. You can go check out lots of his work in Bletchley Park. It's been declassified. It's a great place to visit, not too far from London. Please go say hi to the old boy. Now, unfortunately, because we've been using this as the gold standard, we've built artificial intelligence as we have it today to be really good at lying. We call this hallucination, but let's call it what it is. It's lying, it's fibbing, it's telling the person on the other end what they want to hear, because the way we've trained them rewards them to tell us what we want to hear, to be glib, to sound so good it could be real. This is like when that guy pretends to know stuff that he doesn't know just to get the job or the promotion. We all know that guy. I wonder who these devices we've been building have been learning all of this from. The truth is probably us, because we have a tendency to misremember, elaborate, and insist that we are right, and garbage in, garbage out. These LLMs have been trained on Reddit. What did you really expect? They've also been trained on a lot of historical biases. Most of Rosalind Crick's work was overshadowed by Watson and Crick. She didn't even get an award for it. And I'm pretty sure most LLMs don't correct for that. Now, like a child or a parrot, AI today is really just regurgitating what we've already fed it. LLMs have been trained to repeat our own nonsense back to us in return for rewards. They repeat misinformation, slurs, all our worst qualities as well as our best. We are far from artificial general intelligence until these systems can reason about their impact and self-censor, sort of like turning into an adult. Until then, they aren't, I would say, better than human, but when that day does come, they will finally have surpassed us. So let's talk a little bit about teaching, these problematic teaching methods. Now remember, we all do our best as parents. I'm not a parent, but I have many friends who are, and I respect greatly the work they're putting in to raise the next crop of humans for harvest. But that said, we all do the best we can to bring forth the change in the world that we're responsible for. And this is how we're doing the best we can to train these models. There is unsupervised learning. You just give it the data, and the goal is for it to find patterns and structure on its own. Now, you can think of this as finding solutions without an answer key. It's sort of like dumping all the laundry onto the bed and letting them sort it out, kind of being like, these look like socks. I guess they go together. It's a lot of fun. And then, of course, we have supervised learning. This is like handing someone the answer key along with their workbook. You give them input and data, but you also give them the correct answers, what you're expecting out on the other end. And the goal is for them to learn to predict answers for new data based on the data that they had and the outcomes that you were expecting. Sort of like me when I was homeschooled, where I just basically opened up my textbook and my workbook and the answer key and did my best, checked the answer, did my best, checked the answer. I learned very quickly from that rapid feedback loop. And then there's this one, reinforcement learning. This is when you're given a reward system with the goal of maximizing rewards through actions. We have this, it's called dopamine. Do something good, get dopamine. Do something bad, cortisol. There's a negative feedback loop there. Anyway, this is classic learning through trial and error. You give the model an environment and a reward system, and the goal is to learn the best actions that will get them more of those rewards, like training a dog with treats. And lastly, we have reinforcement learning with human feedback. I've sometimes heard people say human in the loop, but I think that's more towards human UX, but I still feel like just a human being in there is pretty good for training. In this case, a trained model with human raters and examples of outputs with the goal of learning to produce outputs that the humans will prefer. This is pretty tricky to expect out of a model, but this is where we get to that imitation game. You can think of like a comedian trying to figure out which jokes are going to work best by watching for audience reactions. Like when people laugh, that's good. Okay, I'm going to use that one again. And that's where we're getting into that. When I say that the person on the other side looks good today, they give me a reward. I mean, the barista at Starbucks does that too, but that's where it's getting it from. It's a very effective way of training, but it also has some complications. Anyway, once again, I want to state, so how does it adjust to new input? How does it actually learn? We've shown how it can augment those behaviors, but it has to incorporate those learnings back into itself, or else it's not really changing. Once again, it's not magic, it's just math, a lot of math. How are we teaching it? You'll hear a lot of game-changing and powerful, oh God, game-changing, I swear, it's the thing that tells you somebody wrote this with ChatGPT. And I'm looking in Twitter, it's like, this is game-changing. I'm like, no, it's not. It's a wrapper, stop that. So you'll hear these adjectives thrown around, but all of these people are just describing math. Just keep that in mind. They are dazzled and amazed by a big bag of calculations. All right. So there's a training cycle, forward propagation, for error calculation, backwards propagation, Then you update all those weights, the biases, and the parameters. Remember the parameters I told you about? The parameters inside? And then you repeat until it's accessible. This is where you're like baking your model. These are called epochs, by the way. So I did this. Look at our layers, look at our little neurons. I've really tried to make it look pretty and remove all the lines. So forward propagation, we pass the data forward and we are making a prediction, kind of like making a bet. We are running them through each of these is communicating, the weights are updating, we make a prediction. All right, then we calculate the error. How much was the prediction off from the expected results? Were we Marco Polo? Nearer, farther? Where were we? And we pass backwards propagation. This is where we pass the error backwards to discover which weights and biases impacted that prediction the most. Perhaps you favor the bears too much. And then, thank you. I'm glad somebody got that one. And then there's gradient descent, which is like, what did you learn? What did you learn? This is where it incorporates. It's like, I learned that the Chicago Bears are not very good. I will no longer give them a 2x multiplier whenever I pass information through their node. I'm sorry. And if you look at the equation, if you do the deep learning book and you look at the equation, you'll actually be like, this is just like tweaking knobs on a radio. And it is. You usually don't know what you're tweaking, though. So I highly recommend at least building your own little layered LLM at some point. Okay, so you just keep repeating it and over and over and over again, like a washing machine. And you repeat it until the discrepancy between the expectations and the reality are within the bounds that you set. All right, embeddings, where I prove to you that you really are, in fact, just a number. I'm sorry, you are. Embeddings are a way to represent things like words, images, as lists of numbers so that artificial intelligence as we know it can understand and compare them. To a learning machine, you aren't just a number. I'm sorry, I lied. You, to a learning machine, aren't just a number. You're a collection of numbers. So much more than just a number. And so this is me and my loved ones represented as embeddings, strings of numbers. These numbers represent how much we match a description on a scale of -1 to +1. So if you look at this, you can see that I am, I'm more autistic than I am dyslexic, although my partner definitely goes this way. I think I need to update this, by the way. And I'm definitely more athletic. But then if you look down at my sibling, yeah, definitely more athletic than everyone else here, right? And you can see that my best friend, super feminine, super like neurotypical, the kind of person who shows up in a floral blouse with rosé and makes small talk at parties, and definitely not dyslexic, can read the collected works of Jane Austen without having to turn on Audible. Yeah, she's really cool. And, you know, middling athletic, does yoga. All right, there, I've described my best friend to a T. Now, that's just a, oh, wait, yes. And then when you tally them all up, let's see, you can see how related they all are here. Now, I just added them, but if we were actually building a machine to do this, we might, for instance, like if we were trying to match friends and partners, we might be like, let's really add a multiplier here to athleticism so that when we tally them all up, we can see like that the athletic results will really be magnified and downplay the other results, because that's the thing we want to know. Are they going to go jogging at 5 a.m. in the rain or not? Anyway, but if you tally them all up, you'll see that my partner and I actually are very close. If you put us on a 4-dimensional chart, like a graph with each one of these as an axis, I would be right next door to my partner, and my sibling would be a little bit further away, and my friend would be all the way on the other side of that ridiculously shaped cube. All right. So, vector databases. It's time for some human-led visual metaphors, because I just described where these strings are, where do they live. All All right, I'm gonna use these metaphors because this one was really fun for me to learn. Embeddings are, you can think of them as like a set of coordinates, right? Now imagine that those embeddings, they live inside books, right? And we keep the books inside a vector database, which is like a library. We'll imagine it like a library. So all our embeddings, all those strings of numbers that define us as people, we're going to keep them in there. And when we sort the books, people who are closer related, like me and my partner, we have so much in common, they get shelved nearby one another, stored nearby each other. Brilliant. And that brings us to RAG. I know I had to give you that cute little demo so that you'll understand the mind trick that is retrieval augmented generation. This is like giving your AI a library card to go and take things out of said library. So remember what we learned about tokens, right? Pieces of input that are fed into the model through a very small window. Remember, only 4,000 next to like 100 and some billion internal parameters. We're feeding peas into a whale, peas of new knowledge. Models do have token limits. They can't take in more than a certain number. But what happens when you're like, no, I really do want the entire collected works of Jane Austen. I need you to look at them right now. Well, obviously, that's not going to work. Sometimes our model's eyes are bigger than their tummies. That context window, which is what I just described there, can be too small for the files we want to feed it. So when that happens, first, you're going to embed the new data into a vector database where the information is stored near similar information. So we just park all of the collected works of Jane Austen into our vector database there, where they all get shelved and sorted into their appropriate location in that beautiful four-dimensional graph, or 4,096 dimensional graph. All right. When the information, the neat thing is though that when that information is stored nearby, when you log a query now, that query is also put into the vector database. It's also shelved near similar things. In this case, I make a new friend and it goes in and it's stored a little closer to me. And the LLM, when it needs information, it will check out the books, getting just the related embeddings necessary near the one that you just passed it in order to process the query. So it's able to check out just enough information to take through that tiny little context window to deliver what you need. Whew. I know, tortured metaphor, but I hope it gave someone an aha moment. Review time. We are almost at the end of our chance to talk together. While machines learn, well, here we go. You have witnessed the evolution from a narrow AI to one day, far in the future, AGI. You've learned that while LLMs seem intelligent, they're actually recombining the things that we feed them in ways designed to please us, partly by fault of how we teach them. We've also learned that layers of math called neural networks underlie deep learning, and you know that backwards propagation is where the learning happens. You've learned that embeddings are just ways of converting things into sets of numbers so that machines can compare them against other sets of numbers. It does sound like late-stage capitalism. And the LLM will get just the information it needs to reply to your query using retrieval augmented generation, or RAG. Sweet. If you want to see what happens when you build a parser for web pages using LLMs, come talk to me about AgentQL. And yeah, you can find all my socials over there. Thanks for having me. Thanks for enjoying the doodles that I had to share today.
Okay then, and without any further ado, I'm going to introduce our second speaker this evening, Rhea, who's going to be talking about unlocking the potential of dark data with machine learning. Let's have a big hand for Rhea.
Thank you, audience. How are all of y'all doing today? Woo! That's good. I like the enthusiasm. Okay, so coming to my first slide. Unlocking the potential of dark data with machine learning. So as you know, organizations generate a lot of untapped dark data, which they don't utilize a lot, which could be beneficial to the organization. So I'm here to discuss how machine learning can help analyze this untapped data to drive meaningful insights and innovation for the organization. I'm going to walk through the real world examples from industries like healthcare, finance, and education industries, how they can use dark data to make meaningful insights and generate revenue for the organization. Okay, throwing the question to the audience. According to you, what does dark data mean? Yes?
I would go as far as to call it unused data that organizations collect but don't analyze.
Exactly. That's right. Can anyone give me examples of dark data, like unstructured data, which organizations leave out? Okay, so let's define what dark data is. So dark data refers to unused and underutilized data that organizations collect, including customer feedback, emails, social media posts, medical records, and more. According to research, 80% of data collected from the organizations is unstructured and dark, meaning it isn't analyzed or used. The key insight here is that most organizations only analyze a small portion of their data, leaving valuable insights untapped. So machine learning can be the key to unlocking the potential of the hidden resource. The challenge with dark data is that it's overwhelming and often too complex for traditional data management systems. A significant portion of data is unstructured, like emails, images, and customer feedback that doesn't fit neatly into databases. As a result, many businesses are ignoring or underusing this data. In fact, a report from Accenture found us that 60% of companies don't use data for growth. This is a problem because this ignored data contains valuable insights that could drive innovation and improve business operations. The role of machine learning. So as you can see, machine learning can help in analyzing and processing text data and revealing insights in emails, customer feedback, and social media. This can help the organizations make meaningful insights and improve their processes. Image recognition recognizes and analyzes visual data such as medical images or security footage. This can be helpful to detect early signs of diseases or breast cancer. So this would be very important to analyze dark data. Anomaly detection. This detects unusual patterns in data, like identifying fraud or equipment failures. Key machine learning techniques. So the key machine learning techniques used to process dark data. NLP. Research shows that NLP models can analyze millions of customer service emails and social media posts in seconds, extracting valuable insights. And this technique is used to improve marketing strategies and customer success. Image recognition in machine learning models can outperform radiologists in identifying lung cancer from CT scan studies. Studies have shown that AI can achieve diagnostic accuracy of 94% compared to a human doctor with accuracy of just 88%. Anomaly detection can predict equipment failures before they they face failures. Like for example, in industries like manufacturing, it's been used to reduce operational downtime by detecting problems in machinery and equipment early. Healthcare industry. So here's an example how we can use machine learning to uh, help the organization in the healthcare industry. So it's already proven to be a game changer in healthcare. AI models are capable of detecting tumors in medical images, which has the potential to save lives by allowing for earlier diagnosis. And a study published in Nature Medicine found that AI systems outperformed radiologists in diagnosing breast cancer, achieving higher accuracy rates and reducing false positives. With AI, the early detection of diseases such as cancer is improving patient outcomes significantly. Finance industry. So here's another case study to show how analyzing dark data can help to detect fraud detection. Like machine learning identifies unusual activities and can inform financial industries about any fraudulent activities taking place. Uh, Dark data can also be helpful in risk assessment, like machine learning improves credit score by analyzing diverse data, and it can lead to more accurate financial decisions. Machine learning also helps in education industry. As you can see, analyzing from dark data, like analyzing the students' performance, how they interact with the educational contents, can provide insights and make personalized learning for the students to improve their success in their studies and also prevent them from failing. We do have to take into consideration ethical considerations which can impact the data that we work on. So as we unlock the potential of dark data, there are several ethical considerations that must be addressed. First, we must ensure that data privacy and security is maintained. Organizations must comply with privacy laws with GDPR and CCPA to protect sensitive data. A 2020 report from the World Economic Forum found that 87% of consumers are concerned about misuse of their personal data. Additionally, machine learning algorithms must be carefully monitored for biases, like biases in data can lead to discriminating outcomes. So regular audits of model are essential. Data management has to be rigorous, like data quality and reliability for analysis. How to get started with data. So the step one to get started with data is data mapping. Identifying all sources of dark data within your organization. This could include emails, documents, customer feedback, and social media posts. Step two would be to integrate the data, bring this dark data into centralized repository so it can be efficiently stored, assessed, and analyzed. Organize the data for easy processing by machine learning algorithms. Step three would be to use advanced analytics, use machine learning to analyze and unlock patterns within the data, generating actionable insights. And step four would be to like data governance, implement strong, robust data security protocols, and ensure compliance with privacy regulations like GDPR to protect sensitive data. So effective data governance is essential. Because when leveraging dark data, this means organizing and securing data to ensure it is ready for analysis by machine learning algorithms. In addition, organizations must maintain compliance with privacy laws to protect sensitive data. A 2021 survey by Deloitte found that 61% of organizations don't have a formal data governance. Organizations can ensure data quality and inefficiency with strong governance. Organizations can ensure data quality and security, enabling successful machine learning applications. So in conclusion, as you saw the value of dark data in different industries, healthcare, education, and finance, we can utilize dark data to generate meaningful insights for the organization. And machine learning can unlock the potential of dark data, transforming industries, as you saw before, in healthcare, finance, and education. But using the dark data ethically is very important. So in general, my final thought is that dark data is a gold mine. With machine learning, it becomes a powerful tool for growth and discovery. So my key points is leveraging dark data to drive innovation and better decision making, and machine learning turns unstructured data into valuable insights. This is me. I would be happy to connect with all of y'all. Thank you for listening.
I'm from Hongkongers in Britain. Today, I would like to share my journey of building a tool that uses GPT 4.0 to summarize the discussions of and find out the challenges that face in settling in the UK. So just some quick introduction to Hongkongers in Britain. We are a voluntary and community organization founded in 2020. It is the first Hongkongers as organization founded following the UK government's announcement of a humanitarian visa scheme for British nationals overseas from Hong Kong. And we were a grantee to run national programs supporting B&O settlement and integration between 2020 and 2024. We were funded by the UK government, but not now. Well, within the UK Hong Kong community, we are more known for running community events. Well, we take part in London Pride, we run community events, that's what we usually do. So within the community, we are more known for running events, well, support programs, well, helping Hong Kongers find jobs, etc. But we also do research. Research is an important part of Hong Kongers in Britain's work, because we need to tell policymakers, local governments, what are the needs of Hong Kongers and what would be the best way to support the integration of Hong Kongers. So in the past, we publish, so we conduct studies and we publish reports. So over the last 2 years, we published we conducted 4 studies and we published 4 reports. These reports are long, and let's say, we produced a very in-depth reports, but they are not timely. Let's say, we sense that, okay, there are a bunch of issues that Hong Kongers would face when after they move to the UK. But from the time we come to realize these problems, to the moment we decide to conduct a study, collect data, and write up something, it takes up some time. So it's usually more than 6 months, and it's not that timely. And realize that there's a gap that the UK government and the local authorities are not so well aware of the challenges that UK Hong Kongers are facing. And so then we go back to the question. So, how did we know the settlement challenges that UK Hong Kongers are facing? There are 2 main sources. The first source is from the discussions at community events. So when we run the community events, we listen to the conversations and we know, well, what the issues are, or well, when we check our social media or the chat groups, and from the discussions, we know what are the challenges. And we think it might be more, so we were thinking about what would it be possible to produce more timely reports on the discussions of Hongkongers on social media. Then I thought about doing a data reporting service. So what we try to do is to get data from Telegram. So Telegram is a is a messaging app where people can create groups and people can join and have discussions. If you are aware, well, this Telegram app is so widely used by Ukrainians in their fight against Russia. So it has been one of the main sources of news and discussions. But it is similar for Hongkongers. Many Hongkongers use the Telegram app. If you are aware, in 2019, when there were protesters in Hong Kong, many social activists used this platform to organize protests and disseminate information. And so now many Hongkongers still stick to Telegram because Telegram provides good anonymity. So you don't need to expose your phone numbers, and it's relatively safe to use Telegram. So many discussions, you may find many discussions on Telegram, and Telegram and many Hongkongers opened public groups on Telegram, and yeah, it's easy to get access to that data. And so the service that I imagine is to get data from Telegram, do some anonymization, pick in a data set, and say it to an LM and get a one-page summary. Well, it looks simple. And but let's get into the details of my journey building this. Well, the first thing is anonymization. So, let's forget the chat content. The chat content is in Cantonese, and the who column is the column where you find the usernames. The way that I anonymize that the username is to first we add user and get the hash value of the original username and get the first 8 digits in decimal and put it like this. Well, the reason of not completely masking the usernames is because, some discussions are linked. When you look at this chunk of data, you see that, a user may not type everything in a single message. They usually say, the same thing in a couple of messages. So you see that, user may say something here, here, and here. So it is necessary to feed that to GPT-4o, to save, to prevent, to eliminate the need to send a real usernames to to LM is to, let's say, give them a pseudo username, and this is the way that we do anonymization. And also in the UK, I guess you're also aware of the requirements under the GDPR, the General Data Protection Law. We have to comply with the law, and so the way we do is that we do not store the any personal identifiable information in our data sets. And this is the way to make sure that we provide the maximum anonymity to the people that we observe. And also, the Hong Kong community is very sensitive to mass surveillance because of their experience back in Hong Kong. So we need to take care of this expectation. Then we do some classification. So the way that we do classification is like this. So we cannot just simply send the messages that we got and asked LM to do classification for us. As Rachel mentioned, LMs have a have token limits, so we need to consider the token limits. Well, let's say in a batch we have more than 10,000 messages, and we have to split it in we have to split the data set up into subsets, and we split by the number of tokens. The number of tokens is calculated by the tokenizer provided by OpenAI. And after we split a data set up to subsets, we pass these subsets one-to-one to GPT-4o and get the topic for each message. But we are not going to give ChatGPT just classify it. Sorry, classify it. Well, they would go. They would nonsense. The result would be nonsense. So we found out that it would be best to give them some predefined topics. So just give you a quick example of some of the predefined topics that we give to GPT every time we send a request. Well, these topics were generated by ChatGPT, by GPT after processing some of our messages, but we need to do some manual intervention to see, okay, which topics make sense and which don't. Well, they do not necessarily make sense, so you need some human intervention. In our case, we know that there are big issues and small issues, and there's a hierarchy. So we have, let's say, under the big topic, healthcare and well-being, and we have a topic about NHS and support and mental health, etc. So we have a two-layer. So we put the topics into two layers. So we feed that to ChatGPT to help us do topic classification. So, I think it's interesting to mention the prompts that we used, because I guess you also heard of the term prompt engineering, and the word engineering in prompt engineering is important because you need to get the prompt right before you get meaningful results. So I highlighted some phrases in the prompt that we found super important. GPTs are known to hallucinate, and hallucination is a known problem. So we need to be very specific about, okay, explicitly state living problems, challenges, or concerns. So we need to be super specific about, okay, we only need explicitly stated concerns. And we also need to provide examples, like I cannot afford, I'm struggling to, I have difficulty, or I face a barrier. So we also need to provide some examples to guide LLMs. And we also need to tell LLMs, do not guess or infer problems. So we need to be super specific. And so when it comes to implied challenges, implicit or nuanced messages, and we would ask it to, okay, if a message hints at difficulties without explicitly stating them, include only if the implied messages can be reasonably identified and is relevant to living in the UK. So again, you need to be super specific. And also, that's a very important, that we found very important, but since it really hallucinates, if no messages are relevant, please return nothing. So otherwise, it will give you things that do not make sense. So even for, let's say, a null result, you need to be super specific. If nothing is relevant, return nothing. Then so these are the topics that we got from GPT-4o, and you see, so we have message numbers followed by a level 1 topic and a subtopic. Yes, but do you think, well, but do you think them useful? They may be, let's say, too abstract, and it may, okay, understanding workplace rights and anti-discrimination policies, yes, in terms of aggregating numbers to say, okay, there are how many, how many percentages, so how many percentage of messages are about discrimination? Yes, that might be informative, but in the eyes of policymakers and service providers, they may not be super informative. So we need to make everything more informative. And so we did it by doing a summary that I just thought about in the beginning. So so now I tried to ask ChatGPT to do summary. Well, the main challenge again is to deal with the token limit, because we cannot just ask ChatGPT to process all the messages in one go. So first we have to split it up by the number of tokens, generate a summary, and we need to merge summaries up to, let's say, 20K tokens, and ask GPT to generate a summary based on these summaries until we get a single summary document. And this is how we generated a summary from more than 10,000 messages. And so also in the prompt, I will need to include the topics that we identified from the last step. And also, at the final step, there's one instruction that we need to add. Well, let's just show you the some of the excerpts of the prompts that we use in generalizing the summary. So we said, okay, please give us a detailed generalization. And so, if you have a chance to read some reports, in addition to a very general statement, you might also expect some examples or something more specific about the challenges. So contrary to intuition, we need to in a process called generalization, we need to ask GPT to give me some explicit examples. Like, okay, please provide a balanced overview, blah, 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 and showing no critical insights are missed, even if mentioned once only. We need to also combine frequency counts. Just now I said why it is important to retain some identifiers for users, because we need some frequency counts, and we need to ask it to write concrete points, make sure these points are specific. And so we also include just examples like, okay, are there difficulty finding lawyers, confusion over tax filing, etc. As I mentioned, before we get the last prompt, so before we get the last output in the last prompt, we need to add an extra instruction to do a more general anonymization. So in the previous steps, I fed GPT with things like user 1234 says what. And so all these things starting with a user need to be generalized as a Hong Konger or some Hong Kongers. So we need to tell LM that, okay, after process, so at the last step, please, do not mention users, do not say user. Just call everyone a Hong Konger or Hong Kongers. So okay, so this is almost done, and so it's time for me to show you the result. I guess the result is more important. Okay, so this is the summary of UK Hong Kongers chats in December 2024, and for housing and living concerns. Well, first we have stable living arrangements. There are references from Hongkongers trying to find roommates or being forced to leave their current accommodation suddenly, indicating an ongoing struggle to ensure stable living arrangements. And also we have something about shaming and also about, well, energy efficiency. Well, there were questions about efficient dehumidifier brands indicating concerns over indoor comfort and utility costs during cold weather. So if you have been to Hong Kong, you may understand that the climate in Hong Kong is very different from it is in the UK. So some Hong Kongers are trying to adapt to the UK climate, and they need to find the equipment to better adapt to UK climate. And specifically about London, some Hong Kongers also mentioned about, well, the cost of commuting across zones, etc. And job market, well, Hong Kong highlights the difficulty in finding employment due to the lack of networking and poor English skills. And some also mentioned about experience. A few expressed concerns about demand for experience, even for entry-level positions. And some mentioned about overseas qualifications and for access to healthcare. Some mentioned about long wait time for for the NHS. I guess it is more of a common a problem in the UK rather than specific to being super specific to the Hong Kong community. But you still see how how Hong Kongers find or feel about this. Settlement challenges and issues. Well, when it comes to discrimination, it's more interesting. An incident where a Hong Konger faced questions about eating bats from a colleague, which led to HR involvement. So this is an interesting thing because we so a few years ago when at the in the beginning of the pandemic, there were some rumors about Asian eating bats and bats carry some of the origins of the coronavirus. So it seems that some Hong Kongers face this kind of stereotyping, and they faced a bat eating question from the colleague, from his or her colleague, and some also point out some issues with visa application and visa documentation. Well, after reading the summary that I showed you, but did I mention translation at all? No. So it's interesting that in the prompts that we used, we never used the word translation. We never asked GPT to translate for us. It did it automatically. So our prompts are written in English, the data in Cantonese, and after GPT processes everything, GPT gave us results written in English. So this is something that we forgot, but it's interesting that it was not needed at all. We did not need to ask GPT to translate because it was done automatically. So it's pretty interesting. And thank you very much. And I'm Jason Chao, one of the directors of Hong Kong as a Britain. It is a voluntary organization, and I worked for a university before, and I also worked as a software developer. Now I'm looking for a job. So let me know if you I'll come across any opportunities. So feel free to get in touch. And also, if you are interested in inner work or these data reporting servers, you may subscribe to our monthly reports by writing to this email, or you may visit our website to read other research studies from us. Thank you very much.